Welcome back to today's Explainer. I am so thrilled you're tuning in because we are tackling a fascinating, absolutely crucial topic today, and honestly, it kind of flies under the radar. When we talk about the downstream oil and gas sector, refining and marketing operations, our minds almost immediately jump to the big global picture, right? We think about the entire planet. But today we're zooming all the way in. We're looking at the local footprint of these massive refineries. We're going to break down the highly localized environmental and health risks that exist literally in the backyards of these industrial complexes. So let's get into it because this is going to be incredibly eye-opening.
Okay, let's dive into this by contrasting two very distinct threats. On one hand, we've got greenhouse gases. These are the emissions that totally dominate the headlines. Your carbon dioxide, your methane, the big culprits driving global climate change. They're a massive planetary risk. But on the other hand, we have this local risk from non-GHG air pollutants. These are emissions that don't necessarily warn the whole globe, but they create significant, immediate, and highly localized health hazards. It's really the difference between changing the climate over decades and affecting the actual air a community breathes this very afternoon. It's almost like a giant mystery hiding right in plain sight. I mean, while the world's attention is rightly focused on looking up at the global ozone and these huge macroclimate trends, we really have to ask ourselves what exactly is leaking right next door. Because if you live anywhere near a refining operation, the air quality risks, well, they aren't abstract or global at all. They are incredibly specific and they're immediately physical. So today we're going to uncover exactly what these invisible threats are, where they're coming from, and how close they actually are to population centers.
All right, moving right along to Section 1, the culprits. Let's take a look at the 5 invisible air pollutants we're dealing with here.
Now, what's really interesting about this slide is how strictly the Sustainability Accounting Standards Board, or SASB, actually defines this stuff. Refineries are required to disclose their emissions for these 5 specific categories. We've got nitrogen oxides, or NOx, but specifically excluding nitrous oxide. Then sulfur oxides, SOx, which bundles in sulfur dioxide and sulfur trioxide. And rounding it out, we have particulate matter, hydrogen sulfide, and volatile organic compounds. These aren't just some random chemicals. These are the specific byproducts of refining crude oil that pose the absolute most direct risk to our local air quality.
Let's zoom in on one of the most insidious ones on that list, PM10. The strict by-the-book definition here is any airborne, finely divided solid or liquid material with an aerodynamic diameter less than or equal to a nominal 10 micrometers. Just think about that scale for a second. 10 micrometers, that is literally a fraction of the width of a single human hair. Because it's so unimaginably small, this stuff is completely invisible to the naked eye. Yet, it's actual solid or liquid material just floating in the air, easily inhaled by anyone living nearby. It's this sheer microscopic size of this threat that makes it a real game changer for human health.
Next up, we have VOCs, or volatile organic compounds. Now, the definition here is absolutely crucial. These are compounds of carbon that participate in atmospheric photochemical reactions. Notice what the SASB standard specifically leaves out here: methane and carbon monoxide. They aren't counted in the specific localized metric. And why is that? Well, because this metric is laser-focused purely on highly reactive chemicals, the ones that actually interact with sunlight in the atmosphere to create smog and localized pollution. These are the specific carbon compounds directly degrading the air quality right in the immediate surrounding area. Okay, that brings us to Section 2, the crime scene. Where exactly do these releases occur? So, according to the standard, these releases happen across a sort of progression of physical operations at the refinery. First off, you have your stationary combustion sources. Think giant furnaces and heaters burning fuel just to run the place. That's routine. Second, storage vessels holding volatile crude or refined products. Third, flares, which burn off excess gas. But then, look closely at points 4 and 5, equipment leaks and accidents. This is a massive distinction. The first 3, those are part of the designed, routine, daily operations. But leaks from valves and pipes or sudden accidents, those are totally unpredictable, unplanned releases of hazardous pollutants straight into the local environment. Which leads us to Section 3, ground zero. We're talking population proximity and risk. So the absolutely crucial point, the magic number to understand here, is 50,000 people. When we're evaluating the risk of a refinery's local emissions, this is the population threshold that really triggers a much higher level of scrutiny. But what does 50,000 people actually look like when we put it into context?
Well, the guidelines define an urbanized area as densely developed residential, commercial, and other non-residential areas with a population greater than 50,000. So, to put that into perspective, we aren't just talking about a couple of scattered farmhouses near a rural facility. No way. We're talking about dense, bustling city neighborhoods, local schools, and busy commercial districts that are situated right next door to these massive, complex industrial sites. And the human health impacts? They are severely exacerbated the closer a facility is to these dense populations.
Which actually brings us to another highly specific, heavily researched number 49. I want you to take a second and try to guess what this number means in relation to the invisible threat we've been tracking today. We know 50,000 is the population size, so what on earth is 49? It's 49 kilometers. According to the SASB standard, if a refinery is located within a 49-kilometer radius of an urbanized area, that population is officially considered exposed. That means the boundary of the refinery is close enough that, depending on the exposure pathway, things like wind direction or water flow, the people living in that urbanized area are likely to come into contact with a chemical during an accident. It perfectly illustrates just how far-reaching a local threat can actually be. 49 kilometers is a massive radius of potential impact if there's an accidental release of VOCs or hydrogen sulfide. All right, moving on to Section 4, Corporate Accountability. How are we measuring and managing these emissions? This is exactly where the SASB standards come into play, which are now under the International Sustainability Standards Board. These standards provide the strict frameworks used by investors, regulators, and everyday communities to identify and track these exact sustainability-related risks. By standardizing the disclosure, a refinery in one part of the world has to report their local air quality risks using the exact same math as a refinery on the total opposite side of the planet. It basically pulls this invisible threat right out into the light. Just look at how elegantly the standard structures this accountability. They use two primary metrics for air quality in refining and marketing. Metric 128.1 requires the entity to disclose the total air emissions of those 5 specific pollutants we just discussed, measured in metric tons. That gives us the sheer volume of the threat, right? Then, metric 128.2 requires them to disclose the number of their refineries located in or near those areas of dense population, volume of chemicals, and proximity to humans. Together, these two metrics perfectly map out the true local risk. And this brilliantly illustrates the core business reality of the whole situation. This quote, pulled straight from the standard, reveals that tracking this stuff isn't just some environmental crusade. It's fundamental business management. Active management of these non-GHG emissions through technological and process improvements allows refining companies to mitigate the risks of heavy regulations. Plus, think about it. If you're stopping equipment leaks, your refinery is running more efficiently, which obviously reduces operating costs. So, good public health management is ultimately just good business management. So we've tracked the pollutants from their chemical makeup straight through the refinery equipment across that 49-kilometer exposure pathway and right into corporate sustainability reports. I really want to leave you with this thought today. Could you be sitting in an exposure pathway right now? And if you are, is the refinery next door actively disclosing these invisible threats to the public? The data is out there, the standards are in place, and now you know exactly what to look for. Thank you so much for joining me on today's Explainer, and I'll see you next time.